Greetings of the day. So, in today's session, what we are going to see are two topics. First is the need of nested loops, and the second is what are functions in C language. And before that, I'll also discuss some programs with you. So, to start with, in the last session, I have introduced you to the program of printing all the prime numbers which are between a particular range. So, in order to do this program, suppose we want to execute a program in which we have to print all prime numbers between 12 to 30. So here you have to use two looping statements. And first of all, include header files, void main. Now you can accept the range from the user, or here, since it is already given, I may hard code it. That is, you can initialize it directly in your program. So you have to test for all the numbers from between 12 to 30. That is, you have to start from 13 to 29. Between something means excluding those two values. If I say from 12 to 30 means you have to start from 12 and end at 30. But I'm saying between means starting from 13 to 29. So start your for loop from 13 and I should be less than 30. That is, I maximum value in the loop will be 29. And you can declare your variable here, I and I++. So for each of these values from 13 to 29, you will check whether it is prime or not. So which number you will check whether it is prime or not, you have to check for I. So inside your outer for, you have to have another for loop and you have to check for I. Sorry, you'll have an if loop. So you have to use two control if statements. So you have to use two control statements. That is, outside one is a looping statement and inner one is a conditional statement. So if I, you have to test it outside another for, that is, you have to start, suppose you use another variable j over here. So I have declared I and j. J is starting from 2 and it will go up to square root of your number. That is, here your number is I. You are testing for 13. So the number here is stored in I. So less than square root of I, or you can write j into j less than I. That is j square less than number. So first I will be 13. You will check the number 13. Then you will check 14. Then you will check 15 up to 29. And inside here, you will have if. If your number, that is I, mod j. That is, you have to check for each number, that is each I. You have to divide from, you have to find the remainder starting from 2 up to square root of I. So if it is divisible by j completely, then remainder is 0. And if this is the case, make flag as 1. So here you can initialize flag to 0. And if flag is equal to 0 only, then you have not divided, means it is not completely divisible. So only flag is at the end of the inner for loop, flag is still 0. Since flag is 0 means it is prime number. So here what I'll do, I'll only print the value of I. And then if you want a space between, so I'm putting \t. So only if it is divisible completely, then it is prime. If it is not divisible, means flag is remaining 0, it is not becoming 1. Since flag is 0 only, it is a prime number, so I have to print that number. Okay, in else part you have to not use here, only you have to print it if it is prime. If it is not prime, don't do anything. And this is for the first number 13, then for 14, then for 15 and all. So again and again you have to keep making your flag 0. Means what? How this program will run, I will show you now. So see, in outer for loop, I is what? 13 for the first time. 13 less than 30, condition is true, so I'll enter inside my for loop. Then what? Flag is equal to 0. Then in inner for loop, j is equal to 2. And square of j is less than I. Means what? Square of j is 4. 4 less than I, which is 13. 4 less than 13 is true. So I will enter my inner loop also. And then I mod j means what? That is 13 mod 2. Okay? So here the remainder will be not 0. You will get something else. Okay, remainder is equal to 0. This condition, when we test, it becomes false. So what? Flag will remain 0. Flag will become 1 only if my if condition is true. But here if condition is false, so flag will remain 0 only. Since flag is 0, means for the number 2, it is not dividing. So for 2, it is not prime. Now j will get incremented. Okay, this is your for loop. Now j will get incremented. It will become j plus plus, that is 3. Then what will happen? Again I mod j, that is I is what? 13 only. Mod j has become 1 greater, that is 3. So this is also not 0. So this is also false. Okay. So since this is false, again flag will remain 0 only. So since we know 13 is a prime number, so from j is equal to 2 till j is j square, till it is less than 13, you will get for all the values false only. And so if condition will never get executed, so flag will remain 0 only. So finally the flag is 0 after you end your inner for. This is your inner for loop and this is your outer for loop. So inner for loop will get terminated, but since flag is 0 means it is not prime, so from here I can print the number. I will print 13 at my output. Okay, so this was for the first value, that is 13. Now so this if condition is also executed. Now statements of outer for are over. So next iteration you will have I plus plus. So next iteration I plus plus. So I becomes 14 and the same steps you have to repeat. So what is happening? For the numbers from 13 to 29, each time you're checking for each number, you're executing the prime number program. So this is how you will need 2 for loops and an if condition. So what? Total 3 control statements, that is 2 for or looping conditions, that is 2 loops and 1 conditional statement. And I've already told you why I'm doing j square less than I or j less than square root of I. So I hope you have understood how to print the prime numbers in a particular range. So now let me run this program after saving it as a C file. So as you can see, from 13 to 29, that is between 12 and 30, all the prime numbers are getting printed with spaces between them due to \t. So you can change the range as per your requirement. Suppose from 3 to 12. Here again you're getting prime numbers. And if your range is starting from 1, means what? You will not have to print 1. You cannot print 1 because it is neither prime nor composite. So as it is, it will not get printed, because if you divide 1 by 2, remainder is not 0, integer remainder. Okay, so you have understood this program. Now next program that I want to discuss is, you have to find the result of a particular student, how to print his report. First you have to request the user to enter marks of 4 subjects. Then you have to find the total marks, that is marks in subject 1 plus marks in subject 2 plus marks in subject 3 plus marks in subject 4. Then you have to find average marks of the student, means what? The total divided by 4. Average means total number of elements, summation of that divided by, summation of the elements upon total number of elements. You have to find the average. You know how to find it. If marks are greater than or equal to 90, print distinction. If they are greater than 70 but less than 89 or equal to, print excellent. Otherwise, if this range marks fall in, then print good. Otherwise, print pass, improvement needed. And if marks are less than 34, print fail. So here you have to use if else repeatedly. That is called if else ladder. And you have to also take care that total marks should always be greater than or equal to 0, and it should be less than or equal to 100. Since the papers are of 100 marks, student does not have any negative marking, so it can be either 0 or greater, and it should always be equal to 100 or less than. It cannot exceed 100. So what you'll do, you have to take care of this condition also. So only if this condition is satisfied, that is between 0 and 100, only if it is satisfied, you will check for all these remaining above conditions. So what you can have, nested if conditions over here. I'm just giving you an idea. And if this condition is not satisfied, that marks are not, they are lesser than 0 or greater than 100, then what you have to do, you have to print invalid and allow the user to re-enter the marks in the 4 subjects. So I hope you understood this program also. See here, print 5 prime numbers between 5 and 30. So range is changed, program is same. Then print if a character entered by user is vowel or not, using switch case conditional statement. If it is not a vowel, print it is a consonant. Okay, so user will keep entering characters, and only if the character is A or E or I or O or U, that is A, E, I, O, U are vowels. If it is one among them, then you have to print it as a vowel. Otherwise, it is a consonant. So this program also you can try it. Then C program to calculate the sum and product of digits of a number. See, in Armstrong number, reversing a number, palindrome, we have seen how to extract the digits of a number. And here what we have to do, we have to calculate the sum of the digits and the product of the digits separately and display it. So I'm sure you will be able to do this program also. Then next program, to display a given number after adding 2 to each of its digits. Means you have to extract each digit and add 2 to it and then print the number. So the final number is what? It is the number obtained after adding 2 to each digit of the original number. So you can try this program also. Similarly, to calculate the sum of odd numbers and sum of even numbers for the range minus 16 to 18. So here also nested loops, outer loop will handle your range of numbers, and if the number is even, then in the sum of even numbers you have to add it. That is sum plus equal to the even number. But if the number is odd, then add it in the sum of odd numbers. That is, you can say sum e for even numbers, you can say sum o for odd numbers. So if it is even number, sum e plus equal to number. If it is odd number, sum o plus equal to number. So using a same loop, you have to find the sum of even and odd numbers separately. Next, you have to find Armstrong numbers. You have to print the numbers only if they are Armstrong for the range from 1 to 1000. So outer loop will handle from 1 to 1000, and inner loop will check for each number from 1 to 1000. For each number from 1 to 1000, you have to check whether it is Armstrong or not. Okay, same like how we used nested loops for prime number checking, you have to solve this program also. Next program is if you have to find the sum of first 15 whole numbers with and without using looping statement. So sum of first 15 whole numbers means what? Starting from 0, because whole numbers start from 0 to infinity. So first 15 whole numbers are from 0 to 14. So you have to find the sum from 0 to 14. All the numbers ka sum between 0 to from 0 to 14. And this is you can do using looping, and without looping how you will do? There is one formula for the sum of first n natural numbers. Since you are using whole numbers, so 0 plus anything will give you the same number. So you can use the formula to calculate the sum of first n natural numbers. So using formula also, you can find out the sum of the first 15 whole numbers. You have to try this program on your own. Remaining programs we'll discuss later, and I'll give you an assignment also later. So now let us introduce ourselves to the need of nested loop. So we have seen one application here already. That is, if we have to handle a range of numbers and for each number in the range we have to perform certain operation, then nested looping is required. Where else can we use it? We will see now. Now see here. Suppose the desired output is a star. Then what? You can use a simple printf statement to display a star. Let me show you. So what is the desired output? A single asterisk or a star. So when I run this program, as you can see, I'm getting a single asterisk or a star, you can say. Okay, but suppose my desired output is this one. So my desired output is 9 stars. So what you can do, either you use 9 stars over here in your printf, or a better way is you put this single statement into a loop. Okay, so how you'll do it? Either you can use while loop or for loop. For a change, I'll use while loop this time. So initialize your counter variable I is equal to 1. You can start from 0 also as per your requirement or desire. And if I is less than 6, means what? The values of I for which while loop will run are which ones? When I is 1, when I is 2, 3, 4, 5. So 5 times the loop will run. So this star will get displayed 5 times. Okay. And here I'll put this printf statement within while loop. And I also need to increment I. Otherwise my loop will run into an infinite loop. So when I run this program, see the output is what? 1, 2, 3, 4, 5. 5 stars. Now, if I want to print these stars, each star on a separate line, then what? Backslash n I can give. As you can see, I'm getting 5 stars each time on a new line. If you want a space between the stars, you can give backslash t. As you can see, I'm getting spaced stars. Now, this was easy to handle. But what if my desired output is first line 3 stars, next line 3 stars, again next line 3 stars? So here what we will do, we need 2 loops. Means what? The first row can be handled with one loop, and then to print this row again and again, isn't it? We are printing the first row again and again. So to handle one row you need a loop, and to handle printing the rows again and again you need another loop. So here this is the application of nested loops. You'll use one loop for a single row, and to print multiple such rows you'll use another loop. So loop within loop is nested. So let us implement this program. Suppose this is my desired output: 3 stars, 3 stars, 3 stars on 3 new lines. So for I'm declaring I here, then I is equal to 1 as long as I is less than 4, or you can say less than equal to 3, and I plus plus. And here if I say printf star, then can you guess what will be the output? I've already told you 3 times star will be printed. So when I run this program, I'm getting my first row. Now how can I get these rows again and again? By putting this whole for statement in another for condition. So what I'll do, I'll write another for loop here, outer for loop. Let me change this variable to j just as per conventions, and outside for loop will be controlled by the variable I. So I starting from 1, again since I need 3 rows again and again, so less than equal to 3, and I plus plus. So usually for outer loop we use I, and for inner loops we use j. If inside this for loop you have another for loop, then you can use k, and so on. These are how usually programs are written. No problem if you use j outside and I inside. So this whole thing is getting inside a loop. Do you think this will satisfy our requirement? Will this give the output that we are expecting? You can think for a moment. Okay, now we'll run this program. So see here, what is happening? I'm getting my first row, this is my second row, and this is my third row. But they're coming on a single line. Now how to separate is, after your inner loop gets terminated for each iteration, you have to use backslash n. So here what will happen? By this loop, star will get printed 3 times, then new line character. So you'll come to the next line. Your I variable will increase, it will become 2. You'll run the loop again 3 stars on the next line. Then again next line you'll go to, and again print 3 stars on the next line. So since you have already solved these programs these problems in Python, so you will be able to understand better. So see here, you're getting 3 rows on 3 different lines. So we will see such pattern printing programs in our live sessions. For now, let us get to the next topic, that is functions. I hope you have understood the programs and need of nesting looping conditions. Now, what is the need of functions is, suppose you want to group a particular block of statements, since they are all logically related statements. So first advantage of using functions is you can group all logical statements or related statements under a single, or you as a single block of statements. Means what? All the logically or related statements can be grouped together. Second advantage of using functions is you will not have to write your same code again and again. Means what? Once if you have written your code and it is tested and it is able to execute, you can reuse that code. So what? You don't have to write the code again and again. Means what? Duplicate blocks of code will be eliminated. So duplicate blocks of code do not exist. So redundancy is handled. If you have duplicate statements or duplicate blocks of code, then they are called as redundant code. So redundancy can be handled here. Means it can be avoided by functions. Third is modularity. Means what? You can distribute the workload to different functions. If your program consists of many operations or processes, each process you can put into a function. Means you can group a particular process, or you can group all the statements that are needed to execute a particular process under one section. So modularity is possible. So what will happen? Process 1 is handled by function 1, process 2 is handled by function 2, so on till process n handled by function n. So all these functions can be executed in whichever order you want, and you can solve a big problem. So big problem is distributed into smaller sections or parts which are handled independently or dependently. You can solve each part and then combine the solutions to obtain the solution of the bigger original problem. This is called modularity. And finally, what will happen? You can reuse your code. Reusability is achieved. Means what? Since I've told you redundancy can be avoided, means what? You are reusing that same statements again and again, so reusability is possible. These are the main 4 advantages of using functions in your program. Functions and procedures are similar but not the same, but usually nowadays we are interchangeably using these terms, that functions and procedures. There are certain differences, but they're almost same. So we know that C language is a procedure oriented language. So mostly we use functions in C language. Means what? From now on, we'll not be writing large code or large amount of statements in our main function directly, but we'll be using functions in our main to obtain these advantages. So let me show you with an example the syntax of a function. So syntax of a function, let me write first. See, this is the part of your function definition. How you will define your function. First, you have to write return type, means what value your function is returning. Then the name of your function name. Then within parentheses or circular brackets, all the arguments or parameters that you want to pass to your function. So you can call it as a list of arguments you can mention here, separated by comma. So comma operator is acting as a separator here. And then you can have different statements within the body of your function. Means these statements can be used again and again You can have one or multiple statements. And can you tell me which is the last statement usually within the body of a function? So the last statement is return usually. It depends what statement should be the last in your function, but you can use return also. And within brackets or without brackets, you can mention the value that you want to return. So this is the basic syntax of how you can define your function. So this whole thing which I have highlighted in blue is nothing but function definition. This is your function header. Which one is function header? This first thing. This whole thing is function header. Okay, this thing. This whole thing. Now what is function signature, or what is signature means? Signature is equal to the number and the type of arguments that you are passing to your function. Signature is number and type of arguments that you are passing. Type of arguments means whether the argument is an integer or float or character variable or whatever. These are this whole thing. All your statements, and if you are including any return, all these form the body of your function. Now, you have defined your function, but you have not called your function. Unless you call your function, you cannot use your function. So, usually in int main or void main or in your main function, you can call, and you can call one function within another function also. It's absolutely fine. For now, let me show you if you are calling it in main function. So when you're calling it in your main function, what you have to write? You have to write the name of your function. And if you are passing arguments, you have to pass them. Like suppose I write argument 1, comma, argument 2, and so on up to argument n you can have. And the number of arguments that you are passing should be equal to the number of arguments in your list. If they are not equal, it will give you error. But if you are using default arguments, it will not give you an error. So we'll see that little later, what are default arguments. For now, you remember that how many arguments you are passing should be equal to the number of arguments present in your function header. And do not give a semicolon after your function header, because your function definition should not terminate over here. Whenever you give semicolon, it means that your function definition is terminating. But here you don't have to terminate because definition is this whole thing. But you have to give semicolon here after your function call. This is known as function call. So this thing is called as calling function. Your main function is calling your user defined function. You have defined this function, so it is called user defined function. Your main function is calling a user defined function. So your main function becomes your calling function. And this statement is called as function call. Okay, so whenever you are executing in your main, there may be some statements here. And after your function call also, you may have certain statements. So what will happen? All your statements before calling will get executed. When you come across this line, when this line needs to be executed, the control of your program will jump from this line to the header of this line, that is the header of the function. Then it will execute the statements of the function. It may return if you're using return, and the control of your program will come back to your statement, which is after your calling statement. This is your function call. The control will jump back to the statement which comes after your calling statement. that is after function call, whichever statements are there, then they will get executed. I repeat, whenever there are statements in your void, they'll get executed. Whenever it's the turn to execute a function call is also known as function invocation, or it is known as invoking your function invocation, or invoking function, or calling your function. So that time your function will be called means what? Control of your program will jump to the header, then it will execute the statements, it will return a value and come to the statement of your function call, and then execute the statements after function call. Okay, and return is not compulsory. So now let us see an example of a function. So here what? First I want to print a message at the output. Function to add two numbers. Now what I'll do? I will call a function. Suppose the name of the function is add. Okay. Now here I'm not passing any arguments. This is a simple function which is not parameterized. Not parameterized means what? You're not passing any parameters through the function. So it is said to be not parameterized. And this is known as function call. And after this, suppose I want to print the message end of program. So now I've called my function, but I haven't defined it. So what I need to do? I need to define my function. So suppose I'm not returning any value. The return type is void. The name of function should be same here and here. Is the function that you call, that name is add, and here the name of the function is also add. So it should be same. Otherwise your compiler will not be able to find the function. That it will not understand which function to call, and it will give you error. Now within brackets, since I'm not passing any parameters, so here also I don't have to specify any parameters in the function header or function definition. And this is called as function header. And here what I can do, suppose I want to print sum is equal, sum of 5 and 6 is %d. So here I want to print sum of 5 and 6. So simply directly I'm writing a 5 plus 6. So the value 5 plus 6 is 11. That 11 will get placed in place of %d. Okay. So how this will run? Your void main function is there, and above that your void add function is there. So execution of a program always starts from main function. So first you'll print function to add two numbers. This statement will get executed. Then you will call the function add. So control will jump from function call to function header, and then body of the function will get executed. This message will come as sum of 5 and 6 is 11. Then control will jump back to the function call, and then the printf statement end of program will get executed. So let me save this program as sum of two numbers using functions. Now when I run this program, oh, I didn't save it as a C file. Okay. Just a minute. Now when I run, as you are seeing, first statement is what? This one, function to add two numbers. Function to add two numbers. Then what? Control is coming to function call, and then the header is reached, and then you're executing the body of the function. That is sum of 5 and 6 is 11. And then finally, control will jump back to your function call, and then it will execute the statements after add function call. That is end of program is getting displayed. So this was a simple program to add two numbers without returning any value and without passing any parameters. Now what if I want to pass some parameters? Suppose I want to find sum of 5 and 6, so I'll pass 5 comma 6. Now to hold these values 5 and 6, I need to specify the parameters here, like int a comma int b. Okay, so a and b, they will hold the values 5 and 6. So 5 will get stored in a or get assigned to a, and 6 will get stored or copied or assigned to b. And here I will print a plus b. This a and this b are the same as this a and this b. Okay, so here the parameters are passed and I'm adding the parameters here. So it will should give me the same thing, same output. As you can see, same thing. First the statement of main, then the function call, you are passing the parameters. So now what I can say, this is a parameterized function. And then the body of function is getting executed, and then the remaining statements in main function. Now what if I want to return a value? So what I'll do, here I will not print the result. From here, I will return a plus b. Okay, since I'm returning a value here, this value will be considered and it will be the replacement of this function call. Means what I'm saying, this returned value will be the value of this function call. Whatever is returned is the value of the function call. Means what? If here I'm writing int x equal to function call, so whatever is returned by the function will come in place of the function call. So whenever the main function is executing, first you will print this message, then from right to left, means since assignment operator equal to has least precedence, first function call will happen. So this function call will be considered. The control will jump to the function header. It will return a plus b. A plus b value will come in place of this function call, and it will get assigned to the value x. So x will hold the returned value by the function. X will hold the value which is returned by the function. And now I can access this value which is stored in x. How I can access? I can print sum of 5 and 6 is %d. And here I can write what? The value of x. The value of x will get placed instead of %d. So how this will work? Execution of program starts from main. So this first message will get displayed. Then what will happen? Function call. So control will jump to function header. It will execute the statements and return the sum, which will get placed over here. And that returned value will get assigned to x. And here I can access the value of x by printing it, and then end of program. So when I run this, uh, yeah, and since I'm returning a value, so return type should not be void. You are returning something. It is not that you're not returning. Since you're returning, you must change the return type to int. Since a and b are both integers, their sum is an integer. So I'm returning an integer value. And so the return type of the function is int. Okay. So now it will not give error. And let me give a \n over here. So see, First is this printf statement function to add. Then you will get the value which is returned as a plus b, which is stored in x. And then you're printing sum of 5 and 6 is x. Sum of 5 and 6 is x is 11, because the values 5 and 6 are getting copied to a and b respectively. So a is 5 and b is 6. So a plus b is nothing but 5 plus 6, which is nothing but 11, which is getting stored in x. So when I access the value of x, I'm accessing the value 11, and then finally end of program. Okay, so this is parameterized function call and return from the function. So here I'm also passing parameters, I'm also returning. Suppose I don't want to pass parameters, then what? This is also fine. You have to not give the arguments passing, and you have to not mention them here also. So here what a and b, what you can return, suppose you say int a equal to 5, comma b equal to 6. Now this ab and this ab are same. So here what will happen? This a plus b will get added as 5 plus 6, that is 11, which will get stored in x, and you can execute the program. You will get the same result. Now I can also, instead of storing the value returned in x, what I will do, I will print the value of function call. Means what? Instead of this x, in my printf statement, I will write here add function call. Okay, here you don't have to give semicolon after function call. So value of the function call is what? After executing the function, a plus b, that is 5 plus 6, that is 11. So the integer value is returned by this function, that is 11, will get replaced by %d, and you'll get the same output as you were getting before. Okay. Now what if I do int? Now one more thing, when I'm passing arguments like int a comma int b, here also I can pass the values, and I can print the value of function call as in our previous case. Okay, so 5 will get stored in a, and in b what will get stored? 6. So one more thing that I can tell you is, whatever arguments you mention in the function call, they are known as actual arguments. They are the actual values, actual arguments. And these arguments a and b are called as formal arguments. They are not actual arguments, they are the formal arguments which will store the values of actual arguments. Now suppose in my main function I'm writing int a equal to 5 comma b equal to 6, and I can pass these variables here a comma b. Instead of passing integer values, I can pass variables here, and the value of a is what here? 5, and the value of b is what here? 6. So 5 and 6, that is a and b, will get passed over here. Now please remember that the a and b in your main function which you have passed like this, and the a and b in your user defined function, they are not the same a and b, they are different. Why? Because they are in the different functions. Since the functions are different, the values in the functions, if they are same, it is not possible. Okay, means this a and b are different, and this a and b that you are returning here are different. Here you are passing 5 and 6, which are getting stored in a and b, but this a and b is of the add function. This a and b is not of main function. So a and b in your add function and a and b in your main function are different. Suppose here I'm passing a and b, but here I'm using the parameters or arguments x and y, and I'm returning x plus y. This is also valid. Means what? Here the a and b values are getting copied to x and y respectively, and I'm returning x plus y. So you'll get the same output, as you can see. Now, here x and y are the parameters which are catching the values which are passed to them. Okay, from here, function call, I'm passing values here, which they are catching the values. Now, if I have another int x equal to suppose 0 and y equal to 1. Now, when I print the values of x and y, let me see what will happen. See, this x and y and this x and y, are they same? We are checking that. So when I print the values of x and y, let me see what values will get printed. So it is giving me an error. Means what? The parameter names, which are x and y, and your variables x and y, they cannot have the same name. Here x and here x is not allowed. You can have any other variable like a and b over here. Okay? This is running. But here, even if one parameter and variable are same, then it's giving me an error. I hope you have understood this also. Now what I'll do, I can show you that. See, first we have defined the function and then we have called the function. Means what? We are going from top to bottom. First function is defined, so the compiler is aware about the function, and then so we can easily call the function. What if we are calling the function and then defining? Means what? Your function definition, if I remove it from here and if I paste it after void main, means this is the definition of main function and this is the definition of add function. If the definition of add function is after the definition of main function, but you are calling add function within main function, compiler is not aware of this add function. Why? Because it is reading from top to bottom. Since it doesn't have any add definition here, it doesn't know about add function. So when you're calling it here, it will give you an error. See, when I'm running the program, it usually gives you an 1 minute. It gives you an error. So what you can do, you have to declare your function first. Means above your main, you have to write int add, and you can write int comma int. Means what? And give a semicolon. Means the types of your parameter are integer types, and only that is necessary here. Means even if you specify any variable here, it is okay as a parameter. But if you don't specify, then also it's fine. It will not give you error. So compiler is aware about an add function. This is called as declaration, or you can call it as function prototype. This statement is a declaration or prototype. So compiler is aware of add function, and then when you call it, it will not give an error because its definition is here, and the compiler is aware that you are going to define the add function. So add declaration is here. You can call it here and define it after main function. Now suppose I have declared it, but I have not defined it. Suppose I comment out the definition part. Now when I run the program, it is giving me error. Undefined reference. Okay. Now suppose I write a subtraction function also here. And I write here, if I'm writing a comma int b. This is again declaration, and a and b are called as dummy variables. A and b are dummy variables. Just a minute. So A and B are called as dummy variables. They are not the variables or parameters which you will use in your definition. They are not the same. And now I'm defining a subtraction function either before add or before add definition. You can define subtraction function either before add or after add. And here, when you write int a comma int b, this a and b in your function definition is different, and this a and b in your function declaration are different, because even if you don't write a and b here, it is valid. Also, if you write a here but don't write b here, it is valid. and here I want to return a minus b. So what? Here what you can do, either in a variable a you can store whatever is returned by sub function, and you can pass the parameter, suppose 5 and 6, or like how I've done for add function, you can directly print the value which is of the function call. So what I'm writing, sum of 5 and 6 is %d, and difference is %d. So what? There are two %ds, so two values you must specify. That is two function calls. And this type of syntax is only valid when you are returning a value from a function. If you're not returning a value, the function call does not have any value, so it may give error. You can test that at home. So sum of 5 and 6 is add ab, whatever value is returned by this function, and difference between them is whatever value is returned by sub function. Okay. So when I run this program, see, sum of 5 and 6 is 11, but 5 minus 6, that is minus 1, is the difference between 5 and 6. Now you can also accept the values from user. That is, instead of hard coding them int a equal to 5, b equal to 6, I can say printf enter a and b, and then I can write scanf %d since it is integer, and %d since it is integer, ampersand a comma ampersand b. So in a and b, I need to declare my variables a comma b. This is declaration. This is called variable declaration, but this is called function declaration. So you can declare functions and variables, and you can define or initialize your variables, and you can define your functions. When you define your function, it is called user defined function. When the system libraries already have the definition of the function, those functions are predefined or system defined. Now, this printf and scanf are also functions in which you're passing the parameters, which are strings. Enter a and b within quotes is nothing but a string, which is a parameter, which you're passing to the printf function. And printf function is predefined in the stdio.h header file. That is, in your C library, printf and scanf are defined. They are already defined. You are just calling. These are the function calls of the printf function and scanf function, isn't it? These are the function calls. I hope you realize this. So here I've initialized a and b using scanf, and that a and b I'm passing to add and subtraction function. So let me see how this will run. Just a minute, I'll give some \n and all that. So first, this message, function to add and subtract two numbers. Let me change it. Subtract two numbers. Then I'll print the message enter a and b. Then I will enter a and b through the keyboard. Then this printf statement. So first thing, add function will get called, and that will get whatever value is returned will come in %d. Then sub function will get called. Its value, whatever is returned, will get assigned in %d. Now, the order in which these functions are called depends or varies from compiler to compiler. So maybe first sub function is called and then add function is called, or add is called and then sub is called, and so on. So when this comes, suppose add function is called first, then control will jump to definition of add part, and then value is returned and stored in here, and that value can be accessed using %d. Then sub ab, it will jump to its definition. Whatever value is returned will come here and will get stored or replaced by %d. So let me run this program. So see here, function to add and subtract two numbers. I'll enter a and b. Then sum of, let me change this 5 and 6. Let me write it as sum of a and b. And instead of writing and here, if you give ampersand means in English, our shortcut is what? Writing this symbol for and. But since this and is within quotation marks, doesn't have its own meaning. It is just a statement. Whatever you write in double quotes is a string and it will be displayed as it is in printf. So either you can use ampersand, which has the meaning and over here. But in scanf, when we write ampersand outside quotation, it means address of. Okay. When I run enter A and B, suppose 2 and 3. So sum of A and B, oh, just a minute. I will also print the values of A and B here. So in B, I'm getting 117. Oh, you should not use a comma in scanf in percentage. So now when I enter A and B, A is equal to 2 and B is equal to 3. Their sum is 5 and difference is 2 minus 3, that is minus 1. And then end of program. So don't use a comma in scanf between your percentages. It will give you some error. And I'll tell you why it was happening in our future videos. So I hope you understood the concept of nested loops to print patterns or to handle any outer range, like range from 2 to 10. And on those in numbers within the range, you have to perform certain operations. And I hope you have understood after that the programs that I've explained to you and the basics of functions. So that's all for this video. You can watch this whenever you are free or whenever you want to take a break from your studies, and you can understand these concepts. I hope you have understood all of it. If you have any doubt, you can ask me personally. You can message me on WhatsApp. And your any other doubts if you have, I can clear it when we meet on our next live session, that is on 12th of May from 5:30 to 6:30. Thank you.